What up, calculus students? Mr. Messner coming at you. 1.3 homework on asymptotes. You got two kinds of asymptotes. Horizontal asymptotes and vertical asymptotes. A lot more horizontal asymptotes than vertical asymptotes. We only have 2 pages of vertical asymptotes because the horizontal asymptotes are trickier than vertical asymptotes. What do we have to keep in our brains when we're dealing with horizontal and vertical asymptotes? It's like, which infinity goes where and why? Horizontal asymptotes are when we look at plugging in infinity and negative infinity into our function. Figure out what my function is doing to the right or to the left. This is like end behavior. End behavior. So we find that we are plugging in infinity, okay? And we can get answers that are infinity, which means I'm going up. They are negative infinity, I'm going down. I could be approaching a line, y equals a line, going towards that line. I could be approaching 0. Okay, it's like all these things we were trying to figure out. And when we're plugging in infinities, we'll talk about vertical asymptotes later. When we're plugging in infinities, the key is understanding which infinity is the winner. There are different types of infinities. Adding 1 over and over and over and over again will give you to an infinity. But compare that to taking a number and multiplying it by 10 over and over and over and over again. You are going to get bigger numbers faster multiplying by 10 than adding 1. So that's what we keep in mind. Faster things, bigger infinities dominate what's going on. Okay? And we're going to end up with 3 situations where we identify our influential infinities. In this case, there's nothing to cross out. And we see we got x cubed and 5,000 x squared. Well, the x cubed will be a faster infinity that is under a slower. If you have a slower over a faster situation, I don't have this memorized. I just kind of understand. If I'm slowly growing in the numerator, like adding 1, versus multiplying by 10 in the denominator, what is happening? Every subsequent fraction, it's a smaller and smaller value until we approach 0. So slow over faster, boom, we're approaching 0. Our next situation is here, when we end up with a faster over a slower infinity. Just take these things and flip them. And what happens? Well, like 1 over 1, 10 over 2, 100 over 3, 1,000 over 4. My values are getting bigger and bigger and bigger. So our answers are going to be bigger and bigger values, which are approaching infinity. But be careful. You could have a large positive number or a large negative number, like positive a billion, negative a billion. 2 large numbers, but signs are different. So like if you pay attention to this one, the answer is not negative infinity because you're plugging in negative infinity. What we want to keep in mind is faster over slower could have different signs. And what we do is we pay attention to the sign, this negative infinity cubed. A negative value cubed is a negative value squared is a positive value. So this is why I'm saying that would be negative infinity. It's not because I'm plugging in negative infinity. We'll have to check signs later. And the last situation is when we have the same growth over the same growth. Now, if you have the same growth over the same growth, you can think of this negative 4 still being there, and then you got 1 over 1. You got negative 4 still being there, and you got 10 over 10. You got that negative 4 still being there, and you get 100 over 100. What happens is that the growth is canceling. The 1,000 over the 1,000 is going to cancel. Like, they're growing at the same rate, so it's essentially like, they're canceling each other out, and you just get the numerical value, okay? So that's the same over same. So that's the deal is faster over slower, positive or negative infinity, check your signs. Slow over faster, just 0, okay? How do I remember this? I use fractions to help me remember this. Same over same, it's going to be like the coefficients because the growth is going to cancel. All right? So, faster over slower It's either positive or negative. Pay attention to the signs. I'm plugging in negative infinity. Okay, different than the previous one here. This will be -4 times a negative value cubed. That would become a positive value. Negative value squared, positive value. We get a positive infinity. Okay, paying attention to signs, important. We talked about in class our growth rate table. It's very important. E to the x, or a exponential function, sometimes is the fastest. In this direction, this is the fastest. If you're going in the opposite direction, it's going to 0. So it's a no growth function. Log x is the slowest growing function. It will grow, but it will grow very slowly. So this is a slow over fast. In terms of the infinities. Slower infinity over a faster infinity. 0. Okay, I'm trying to catch you on these. Look, I got 5 to the x and 5 to the x. I got the same one, but in both directions, this is important. If you plugged in infinity, okay, 5 to the x, 5 times 5 times 5, we are like quintupling our values every time. Exponentially fast growth. It's faster than x to the 5th. This is a faster over slower situation. So this is going to positive infinity, positive positives. If I plug in negative infinity though, this is a no growth function. It's almost like I can just like get rid of this or understand 5 or a number to the negative infinity is the same as that, which is going to get smaller and smaller and smaller, approaching 0. I like to think of negative powers as dividing, positive powers multiplying, because it's true. So the answer to this is just 0. It's essentially like 1 over 5 to the positive infinity times negative infinity to the 5th. Like we have something getting smaller and smaller and smaller. 5 to the x over 6 to the x, a lot of students get confused. They think it's the same growth. They think the answer is going to be 5, 6, but the answer is not 5, 6. 5 times 5 times 5 times 5, continuing on. 6 times 6 times 6 times 6, continuing on. Does not simplify to be 5, 6. 6 times 6 times 6 times 6 is growing faster than 5 times 5 times 5 times 5. This is not a same over same. This is a slower over faster, which is always 0. We don't care about positive or negative. Okay, E we need to know is 2.717. Pi we know is 3.14. So e to the x is actually going to be slower than pi to the x. This is slower over faster again. 0. How do I remember this? I think about this. Slow over faster. Faster growth in the denominator, slower growth in the numerator. Values are getting smaller. Now this is the case where we have a same over a same. The same growth cancels. We just have our coefficients. Be careful though. Many people might think this is faster over slower because you think this is 10 to the x. This is not 10 to the x. That's not right. This is 2 times 5 times 5 times 5 times 5. This is 6 times 6 times 6 times 6. This 2 is not making a dent into the growth. 6 times 6 times 6 times 6 will produce larger and larger values faster. This is a slower over faster again, which approaches 0. Okay? Now, these are easy. There was nothing else besides looking at the numerator and the denominator. The next page, we see this addition stuff. We see this extra stuff going on we have to figure out, okay? Now, here's the key. We don't just compare like the top and bottom right off the bat. We really compare like the fastest growing thing in the top and the fastest growing thing in the bottom. Like what is the most influential infinity coming out of both the top and the bottom? If I take 299 times a large number and add that to 2 times the same large number squared, I tried to show you in class. If you don't understand it, we can talk about it more. But like, the value you're going to get from the large number squared times 2 is going to be so much bigger than 299 times the large number that it will essentially be like adding a very, 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 very small decimal to a very, 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 very large number. It's like adding like a 2,000th to 1. Like add two numbers together, one thing, a 2,000th of the size to the other thing. You're barely changing things. And imagine if it's like more than just like 2,000ths of a size. Like talk about like minusculely small compared to something really, really big. The reason why I say that is like this infinity is not influential. It's not doing anything. We can ignore it. I'm going to cross it off. Adding 1, 2, 3, 4, 5 to this large value being squared times 2 is insignificant. You could ignore it. You take this question here, you turn it into a question from the first page. Okay, once you get the questions from the first page, it's easy to do. But sometimes we just got to understand why this question is thought of like a first page question, where it's just, okay, 2x squared over 0.1x cubed. This is a slower over faster, again, going to 0. Okay. The 3x squared infinity, insignificant compared to the x cubed's infinity. The adding 99 is not going to do anything. You get 2x cubed over 4x. I like to pay attention now to the sign. You could simplify, but I don't like to simplify because you can't simplify all the time. So I'm just going to stop here and say, okay, if I plug in a negative value, cube it times 2, I will get a negative faster. If I plug in a negative value multiplied by 4, I'll get a negative slower. So we're paying attention to signs. Cubing, odd powers will retain signs. Even powers make it positive. A negative divided by a negative is a positive. So this is why my answer is positive infinity. Okay? The 200, insignificant. Get rid of it. Don't pay attention to it. The 2x is infinity. Insignificant compared to x cubes. I have negative 5x squared over x cubed. You could plug in infinity now. Or you could simplify if you wanted to. I'm not going to simplify. I'm just going to leave it like this. I get a negative slower over a positive faster. So going to 0. I don't really care about the negative slower over faster. Slowers over fasters are always 0. Log x, insignificant infinity compared to 2x. Sin x does not grow. It is a no growth function. It just goes up and down. It'll add as much as 1. It'll subtract as much as 1 from 5x is infinity. It's not doing anything. Just pay attention to 5x and negative 2x. If you try to like worry about signs, you'll find out that you won't have to worry about it. Like if you're plugging in a negative, like the negatives will cancel. It's like whatever you get there, they'll cancel. This is one of those sames over sames. The answer is negative 5/2. All right. Most common mistakes made on the horizontal asymptote questions is always assuming that the exponential function will always win and that you cancel off this and you cancel off that. I mean, you cancel off the 8x and you're talking about negative 6x and 3x. You are wrong. If you remember a number to the x as x approaches positive infinity super fast, yes, that's what people remember, but what they forget is that as you approach negative infinity, this thing to the x turns into 0. No growth, okay? Biggest mistakes made is students always thinking that this is the fastest growing function, but if you go to negative infinity, that guy is a big fat 0. It's not even an infinity. It's not even a slow infinity. It is 0. We are approaching 0, dividing by 6 over and over and over. We're going to make it smaller. This is approaching 0. It's not even a slow infinity. So I really look at 4x over negative 8x. We see the same over same deal. We get the answer negative 1/2. You might be thinking, well, what about the signs, Mr. Messer? Well, it's like you could think about 4 times a negative same over negative 8 times a negative same. Again, the negative sames are going to cancel. You end up just with the coefficients. This is a good question because it's designed to trick you. You might think about canceling the 1 and the 2, and like you can. Just don't cancel the 2x. Don't like get rid of it. Can't just get rid of this. You got to think about what you would get if you distributed everything. If you distributed everything, you'd get 6x squared plus other stuff. What's the other stuff? Don't care. The bottom, you got 12x. Don't care about that compared to the negative 5x squared. So the other stuff is going to be insignificant in its infinities. We end up with 6x squareds over negative 5x squareds. That's a deal of the same over the same. So your limit's going to be that negative 6/5, or however you want to write it. Okay, if I plugged in positive infinity, now the exponential function wins. The exponential function wins. Now we're talking about the fast guy. And paying attention to signs, I have negative 6 to the x over 3 to the x. This is a faster in the numerator. Plugging in infinity. Negative faster. Positive slower. Faster over slower. Bigger and bigger values. Bigger positive values or bigger negative values. Cool. Same deal. Plugging in positive infinity, the exponential functions are super fast. Log function, the slowest. 2e to the x over negative 4 to the x. Again, it's not 2 times e. You can't multiply those numbers together. It's 2 times e times e times e times e times e, compared to 4 times 4 times 4 times 4 times 4. 4s multiplied by each other, quadrupling our values over and over again would be faster. So we are faster in the denominator. We are slower in the numerator. If that's a negative, it doesn't matter. Slower over faster, we are going to 0. Okay. Other tricky ones involving signs, maybe some other things coming up here. So like challenge yourself to try these. If you were to plug in infinity, maybe you would think, oh, that 3 is insignificant, but like pump the brakes, hold on a second. Let's first think about plugging in infinity there. Okay, the 200's gone. You get a slow over faster. So slow over faster is 0. Well, that means your answer is 3 plus 0. That 3 means a lot. You're not going to cross it off because it's still there. Like, it's not going to be 3 plus x plus this fraction. Then you could ignore the 3. It's 3 plus the fraction. Figure out what's going on in the fraction. Then see if you can get rid of the 3. Same thing here. This is a great one. Tricky one because it's the cosine of that. It's like, okay, if I'm plugging infinity just to this fraction, I see it's a slower over faster. Now, what's slow over faster? Again, guys, you're not gonna memorize this. You're gonna understand or like be able to recall it in your brain. Slower in the numerator, faster in the denominator. The fractions are getting smaller and smaller. They're approaching 0. Okay. So this turns into cosine 0. The cosine of 0 is 1. See how it's a fun little puzzle right there? So it's like you work inside the fraction, then you worry about the cosine later. If I plugged in infinity here, you might be like, oh, cross out the 3, but it's like this 1 over x is in the power of e. you think about like 1 over infinity, well, isn't that just like e to the 0? What's e to the 0? That's 1. Oh, yeah. Something to the 0 power is 1. So 1 plus 3 is actually 4. It's a fun one. This one is like the same. You'd be e to the sine of 1 over negative infinity plus 2. 1 over negative infinity is going to 0, so I got e to the sine of 0 plus 2. The sine of 0 is 0. So you get e to the 0 plus 2. E to the 0 is 1. 1 plus 2 is 3. Okay? These square roots are tricky. So let's just like look at what we got going on here. You know, if I were to look at the numerator, it's like the 15 is gone. If I look at the denominator, it's like the x is gone. Now, let's just pause right here. Pause. If you plugged in infinity, the numerator is going to be a negative, and the denominator is going to be a positive. How do I know the denominator is going to be a positive? Well, like 16 times a positive value squared is a positive. The square root of a positive value is a positive value. When we use a square root to solve an equation, we get this whole idea of a plus or minus. But the square root of a positive is a positive. The function y equals the square root of x. To be a function, 9 goes to 3. 9 doesn't go to 3 and negative 3. Okay, so that's the first thing. So I'm going to look at my signs first. I know I'm going to have a negative answer if I get an answer. Well, now let's look a little bit more about what infinity is bigger. Well, if I take the square root of 16x squared, I get 4x. So I get negative 2x over 4x. Now, you're like, oh, this is a same over a same. So the answer has got to be negative a half. And you are exactly correct. The answer is negative a half. Cool. I think I was supposed to put a negative in front of this. So let's do that now. Because watch what happens. Let's think about if I plugged in negative infinity into the top and the bottom. Well, if I plugged in a negative infinity into the top, I would get a positive value. If I plug in negative infinity into the bottom and I square it, it becomes a positive, times 16 stays a positive. Square rooted becomes a positive. Here's where things get confusing for students. You do the same process. You get negative a half. And I tell you, no, that's not right. The answer is positive a half. And you're like, what are you talking about, Mr. Mester? You're saying, like, if you square root the 16, it's just positive 4. The square root of x squared is just x. It's like, that's where things kind of differ. It's not just x. Turns out, and the only way that I can describe why we just have to check our signs, and it's almost like don't even pay attention to this negative 2 when you're getting the number. Just like pay attention to signs at the beginning and then the numbers later. Essentially, what I'm trying to tell you is that like this x here actually could have been a positive or negative. It's not that this x cancels. It's that this is like a plus or minus x, which means the x's cancel, but like you got to look at the sign because you don't know what the sign of this 4 is, whether it's positive or negative. How do you figure out the sign of the 4? Well, go back to the original equation before taking the square root. Plug in the positive or negative and figure it out, okay? So these are very tricky to a lot of students, but now that you kind of understand this one, see if you can do the next one, okay? Worry about the signs first. Worry about the numbers later. Understand that the denominator, or wherever you're like square rooting x squared, the sign is a little bit not obvious, and kind of go from there. All right, try that. I'm going to get rid of the 8 and the minus 3. Just pay attention to the signs. I'm going to get a positive over a positive when I plug in a positive. Now, when I simplify, I get 3x over 4x, but again, that x up top could have been a positive or negative. So, like, my answer is either positive or negative 3/4, but, like, let's find out which one it is. Well, I already know that it's going to be positive 3/4 because of my sign analysis. Over here, again, the 8 doesn't matter, the 3 doesn't matter. But let's check signs. If I plugged in negative infinity, squared times 9, square rooted, a positive number in the top. If I plug in a negative infinity in the bottom, it's a negative. So we might think the answer is 3/4, but it's actually negative 3/4 because of my sign analysis. I get this 3 plus or minus x. I get this 4x. Yes, we think it's 3/4, but like we're not sure. Check your signs. It's positive or negative 3/4. Check your signs, and this is what I got. Okay? Now, these last 4, you're asked to find the horizontal asymptotes. Now, when you're asked without direction, you're not given a limit, you're asked find the horizontal asymptotes. You're asked to like determine the end behavior. You must look both to the right and to the left. Okay, you got to look in both directions, and I think all the ones that I gave you have 2 different answers just to try to trick you. Won't always be the case, but try to trick you for this one. So, let's treat them differently. I'm going to just do the problem like twice here. If I plugged in positive infinity, positive infinity, e to the x wins, 2x bad, 5x 2, insignificant. I would just pay attention to negative e to the x over 3e to the x. The growths cancel. I just end up with negative 1/3. Hooray. But if I looked in the other direction, this is where they get you. Oops. Okay. If I looked in the other direction, e to the negative infinity is the same as 1 over e to the infinity, which goes to 0. There's a no growth. It is 0. This is 0. It's not even infinity. It's 0. It's gone. 2 to the x, or 2 times x, that's an infinity. Negative 5x, that's an infinity. Adding 2, not going to do anything. This one, I would look at 2x over negative 5x. It is a same over same situation. The negative growth is going to cancel, giving us negative 2/5. Okay? Try the next one out. I'm purposely trying to trick you, see if you can figure it out. If I look to the right and to the left. All right. To the right, usually easier for students to do because it's like, yes, this guy's exponential growth, that guy's exponential growth, that guy's gone, that guy's gone. I get negative 3 to the x, 4 to the x. Okay? This is not a same over a same. This is a slow over fast. Times 3 times 3 times 3 will be slower than 4 times 4 times 4 times 4 times 4. Slower over faster, that goes to 0. That is my first kind of end behavior horizontal asymptote. If I go in the other direction, this goes to 0. It is a no growth function. It's gone. This goes to 0. It's a no growth function. It's gone. I end up with 2x squared over negative 5x squared. This is a same over a same. This is another negative 2/5. Okay, cool. It's really the same as f. All right. Same deal for h and j, and then we'll shift gears. If I plugged in positive infinity, 4x squared wins. 3 to the x wins. 4x squared over 3 to the x. Slower over faster. Remind yourself why it's 0. Don't try to memorize it. Okay? Always be able to go like 1 over 1, 2 over 10, 3 over 100, 4 over 1,000. Understand, don't memorize. In the other direction, cool. In the other direction, 3 to the x is 0. That's no growth. 4x squared is still faster than negative 5x. Okay? Like negative values squared, still going to be bigger than just negative values. So I end up with 4x squared over negative 8x squared. The growths will cancel, give me negative a half after simplifying. Last two horizontal asymptotes. To the right, 3x, 6x, no big deal. I just get negative 4x over 8 of the x. Slower over faster. To the left, the negative 4 to the x, the 8 to the x. 0, 0. We end up with 3x over negative 6x, which is negative a half. It's funny how I got the same answers over and over and over again. But anyways. All right. Cool. 2 more pages. Shifting our gears over to vertical asymptotes. On your continuity quiz, if I asked you, hey, examine the continuity of that function, you would say, oh, the denominator equals 0 and x equals 5. If I plugged in 5, I'd get negative 4 over 0, which is why this is a non-removable infinite discontinuity. Hooray! Now we're going further. Now the question is, okay, great. You're telling me that at 5, there's this vertical asymptote, x equals 5. Cool. Well, that means I'm going like up or down towards positive infinity or negative infinity, depending on the direction. Can't do both. One or the other. To the right of 5, am I going up or down? That's what we're determining. Okay? Now, what we do is like what we did on the first day of the unit, is we think about, plugging a value that's approaching 5 that's a little bit bigger than 5. Plugging that in there. And I think about plugging in there, and I'm like, okay, well, negative 5.001 minus 5 is going to be a number very close to 0. Now, usually we just put 0 down, and then we say, well, it's a closer number to 0, but it's like going to be 0. Boom, that's a vertical asymptote. But now I want to pay attention to things. I want to pay attention that, yes, we are close to 0, but we're close to 0 in positive. How do I know we're close to 0 and positive? Just think about it. 5.0001 minus 5, I'm going to have a positive leftover number. Okay? Now think about what you get if you take a negative number divided by something really, 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 really small. Like even think about 4 divided by a half is 8. 4 divided by a fourth. 4 divided by a fourth is 16. 4 divided by 100th is 400. Every time you divide by a fraction, you get a bigger thing. So divide by bigger and bigger, or like smaller and smaller fractions, bigger and bigger numbers. Anyways, this is how we're going to get our direction of infinity. This is how I'm going to know, oh, we are going to be approaching negative infinity. So to the right of 5, I'm going down like that. We not only know that we have a vertical asymptote, but we know the behavior around our vertical asymptote. If you plugged in 4.999, subtracted 5, we'd get this number 4 divided by something very small but negative. So that negative 4 divided by negative 0.000001 is going to be a very, very large positive value. This is what you're discovering, to the left of 5, you are going up. And this is our asymptote analysis for vertical asymptotes. All of our answers are going to be y equals positive infinity and y equals negative infinity. Because around an asymptote, that's what you're doing. You're either going up or down. You're never going to touch this vertical line. So vertical asymptotes, limits equaling infinity, positive or negative. Horizontal asymptotes, plugging in infinity in for x, getting numbers or zeros or infinities. Make sure we distinguish the two. Let's do some more. -1 to the right. First thing is make sure you know what to the right of -1 is. To the right of -1 would be like -0.9999. Okay, so if I took -0.999, added it to 1, and also took it and squared it. Well, if I took -1 and squared it, I'd get 1. If I take -0.999 and squared it, I'm going to get something close to 1. Now, is it a little bit less than 1? Sure, it's probably a little bit less than 1. But I actually don't care because 1 to the left and 1 to the right is still like +1. And understanding that it's a positive value is actually the most important thing. It's not 0. And 0 to the left and to the right changes signs. 1 to the left and to the right doesn't. So I'm just going to say it's close to 1. Here, 1 plus -0.999999 is going to be close to 0 but positive. This is how I know we are going to be approaching positive infinity to the right of -1. To the left of -1 at -1.00001, if I plug that in, and again, square it, I'm going to get something close to 1. Now, it might be bigger than 1. But I don't care, because to the right or to the left of 1 is still +1. It's to the right and left of 0 that's important, because -0.001 plus 1 would be something close to 0 but negative. It is this positive value divided by something infinitely small and negative that's infinitely large and negative. And let's just continue with that. 2.999. Well, 2 minus 2.999 is going to be close to -1. Now, is it plus or minus? I don't care. It's still negative. It's 2.9999 subtracted from 3. That is going to be close to 0 and positive. That's really important. That's what I pay attention to. That's why I get negative infinity. If I'm to the left of -4, -4.0001, multiplied by -2. Yeah, it is +8. It might be 8 to the left. It might be 8 to the right. I don't care about that because it's still going to be close to +8. The sign's not going to change. We're fine. Again, this positive or to the left or to the right of -1 does not matter because it's still -1. If I take a value like -4.001 and square it, though, this is important. I am going to get a value that's probably bigger than 16. Now, I'm going to write 16.001 just as an example. I don't know exactly what it is, -4.001 squared. I'm just going to be like, well, like, it's got to be bigger than 16 because, like, the value is, the absolute value of, like, this is bigger than 4. So it's, like, further away from 0. So subtracting that from 16 gives me something close to 0 and positive. So I got a +8 and I got something close to 0 and positive. That's why it's going to be approaching positive infinity. Just gotta practice, you know. These are fun, tricky puzzles. If you treat them as such, you're good. If you don't struggle and you just like guess, then it's gonna stink. -3 to the right is -2.999. -2.999 plus 2 is going to be close to -1. I don't care about left or right at all because it's still -1. -2.999 squared is going to be a little bit less than 9. It's probably like 8.999. I'm just using that as an example. So I know that when I subtract, it's going to be something close to 0 and positive. This is going to be negative infinity. If I'm plugging something to the right of negative 5, something to the right of negative 5 is negative 4.999. Okay, times 3 is going to be something close to negative 15. Is it to the right, to the left? I don't know. I don't care, because it's like something close to 5 times 3 is negative 15 to the right or to the left. Don't care. The sign is still negative. Negative 4.999 plus 5 is going to be something close to 0 and positive, so I get something large and negative. Cool. Last two questions. I have a vertical asymptote at 3 and a horizontal asymptote at negative 2. What must be true for A and B? Yo, guys, I'm just going to let you know, like the last page, this is where quiz questions and test questions come from. This will definitely be on your quiz. This will definitely be on your test. Don't just stop working. Try to figure this out, okay? So, we understood horizontal asymptotes are when you plug in infinity. Now, if I plugged in infinity into this, the 3 won't matter, the B won't matter. You just get ax squared over x squared, which is a same over a same situation, which just leaves you with A. Well, the horizontal asymptote is at negative 2. That's what A has to equal, negative 2. Now, for this part with the vertical asymptote at x equals 3, I'm going to go back to lesson 2, the continuity lesson, which says when I plug in 3, I'm going to get a number over 0. When I plug in 3, my denominator has to equal 0. When I plug in 3, my denominator has to equal 0, B has to equal 9. It's not even doing anything with like factoring. It's not even looking at a one-sided limit. It's just kind of using the day 2 kind of understanding of like 0 over 0 whole, number over 0, vertical asymptote. Why is it a vertical asymptote? It's because like as you get close to 3, you're going to get a number divided by something close to 0, which is big. All right, cool. Same deal here. We get y equals 2 and x equals negative 1. So if I looked at plugging in positive infinity, I should get 2. If I plugged in positive infinity, I don't care about the 3. I don't care about the 3c. That's gone. That's gone. I just care about the negative dx cubed over x cubed. Oh, same over same. The x cubed growth canceled. Negative d would have to equal 2. Okay, d equals negative 2. What's the other thing? Vertical asymptote at x equals negative 1. If I plug in x equals negative 1, I'm going to get a number divided by 0. Well, if I plug in x equals negative 1, the denominator is negative 1 minus 3c. That has to equal 0. Add 1 divided by 3, I get negative 1/3. The question is, what must c plus d be? It's a way to like make this a tougher question than being in multiple choice. Like if this is a multiple choice question, this is how I'd get you to have to find the right answers yourself. No like guessing and checking. And c plus d is negative 1/3 plus negative 6/3, which is negative 7/3. Yo, you got to do these, okay? You can't get caught by the tricks. We'll do plenty of practice problems so that you don't get caught by the tricks. But, like, if you don't actually try these, you don't get used to all the, oh, crossing this off sometimes, crossing this off sometimes, you know, like situations that trip up so many students. So, good luck. Review day on Thursday, test on Monday. Let's go. Mr. Masters.